Hi friends, here we discuss the next in-text question from Haloalkane Haloarenes. Question number is 1013. In this question, we are asked to find the major monohalo derivative in each of the given reaction. The first reaction, cyclohexanol is treated with the thionyl chloride. We are familiar with this reaction. It is Darcy's reaction to substitute OH in an alcohol by halogen, chlorine. So during this reaction, OH is replaced by Cl and we have chlorocyclohexane, and the two other side products are SO2 and HCl, both of which are gases which are escaped by themselves, which is considered to be an advantage of Darcy's method because less tedium of purification is there. Okay. Next, it is para-nitro or 4-nitro-ethyl benzene. Here the naming is based on alphabetical priority. E of ethyl comes before N of nitro. So it is called 4-nitro-1-ethyl benzene. Okay. It is treated with a bromine in the presence of heat or light. Then we know it is the case of allyl halogenation. Okay. So what happens here? Due to this kind of reaction, allyl carbon is this, not the terminal one. So one of the hydrogen here get replaced by bromine. Okay. So the product will be this. Okay. It is 1 bromo 1 phenyl ethane. Okay, 1 bromo 1 phenyl ethane, or you can call it 1 bromo ethyl in bracket 1 bromo ethyl in bracket benzene. What benzene? It is like this: 1 bromo 1 phenyl ethane or 1 bromo ethyl benzene. Why this 1 bromo ethyl in parenthesis? Because it suggests that this one is not of benzene ring but of the alkyl group which is attached to the benzene ring. So more preferable name is 1 bromo ethyl benzene. Okay. Now the third case. You are treating 4-hydroxymethyl phenol. 4-hydroxymethyl phenol. 4-hydroxymethyl phenol with hydrogen chloride in the presence of heat. We know only alkyl OH, alkyl substituted OH group will be replaced in this reaction and not OH directly bonded to the benzene ring, because that OH has double bond character. The OC bond has double bond character due to resonance, so it is not directly substitutable. Okay, in that case, only this OH is replaced by chlorine. We get what? 4-chloromethyl phenol. 4-chloromethyl phenol we will get in this particular case. 4-chloromethyl phenol you will get there. Okay. The next, fourth one. It is 1-methyl 1-cyclohexene. 1-methyl 1-cyclohexene. Okay. It is treated with HI. Here the addition, the major product is decided by Marconi-Cox rule. And both the CS3 and I comes on the same carbon. However, here the majority will be comparatively a lesser majority. Why? Due to steric crowding. So this is not the highly exclusive major product. It is to be just above 50%. The other will also be in a considerable amount because due to the steric crowding at that center, the other product will be also preferred, but here we are asked to write only the major product, so we restrict the answer to be this only. The next question. It is the next one is the familiar Finkelstein reaction, where chloroalkane or bromoalkane is converted to iodoalkane by treating with the sodium iodide in acetone medium. What is the advantage of using acetone? Acetone dissolves bromoalkane as well as sodium iodide. Okay, that's the advantage. And at the same time, when the products are formed CS3, CH2I and NaBr, the NaBr being more ionic in nature gets precipitated from the organic solvent acetone, which is predominantly covalent. So what is the advantage of that? The reverse reaction is nearly prevented. That CH2I does not react with NaBr, giving back the reactant. So reaction is almost unidirectional in the forward direction only. That's the advantage of taking acetone here. Please go through that portion. We have already discussed. And the last case, sixth one, cyclohexene and bromine are treated. If you are treating cyclohexene and bromine in cold, or what you will get at a low temperature, bromine get added across the double bond. You get 1,2-dibromocyclohexane. But here the process is carried out at a high temperature. So what happened at a high temperature? Allyl halogenation is the reaction through free radical reaction. So here we get an allyl brominated product. It is what will be its IUPAC name. You have to remember. We have to give priority to double bond over bromine. So to give minimum number of bromine, we have to now number like this: 1, 2, 3. 3-bromocyclohexene. The product will be 3-bromocyclohexane. 3-bromocyclohexene will be the product. Remember, during heating, it is allyl bromination that is happening. So it will be brominated at a position next to the double bond. So we have 3-bromocyclohexene through a free radical reaction. Hope you understood all these things. Okay. This is an additional question, not from in text. Which is not a perchloro compound. What is meant by perchloro compound? A perchloroalkane or alkene is that alkane or alkene or any hydrocarbon in that case, from which all hydrogen has been replaced by a particular halogen. That's called perhalo hydrocarbon. Let's check one by one. Here it is obtained from ethene, where all the 4 hydrogen atoms are replaced by chlorine. So it is a perchloroethene. It can be called perchloroethene. It is not an IUPAC name. It's just a common name, trivial name or trade name. And this, it is benzene from which all hydrogen has been replaced by chlorine atom. So you can call it perchlorobenzene. Okay. Its IUPAC name 1, 2, 3, 4, 5, 6 hexachlorobenzene. This is CCl4, methane from which all hydrogen are replaced by chlorine. It is carbon tetrachloride or IUPAC tetrachloromethane. Okay. And lastly we have this. What is this? 1, 2, 3, 4, 5, 6 hexachlorocyclohexane. 1, 2, 3, 4, 5, 6 hexachlorocyclohexane. Remember, as it appears from the image, it is not a common without hydrogen. You know, at every corner there is one hydrogen also. So it cannot be considered as a perchlorocyclohexane compound. If it were perchlorocyclohexane, there would have been 12 chlorine and no hydrogen. Okay. But this is having 6 hydrogen and 6 chlorine. So it is not a perchloro compound. So our answer for this question is 4. Okay. See, it is hexachlorobenzene. It is benzene hexachloride is its common name. See the difference? Hexachlorobenzene, a substitution product. Okay. And this is, you can consider this to be benzene to which chlorine HCl has been added. So it is an addition compound. Okay. So hexachlorobenzene, benzene hexachloride being the common name. Its IUPAC name is 1, 2, 3, 4, 5, 6 hexachlorocyclohexane. Okay. The next question. The correct order of dipole moments of CH4, CH3Cl, CH2Cl2, CHCl3 and CCl4. Methane, then hydrogen atoms are replaced by chlorine one by one. All the set is given. I haven't written the options to save time. C, we cannot guess because due to its structural complications, there can be cancellation or enhancement of dipole moment, etc. etc. So only based on experimental observation, we can arrange them in the order of decreasing or increasing dipole moment. Experimentally, it has been proved that CH2Cl2 is having the highest dipole moment. Methylene chloride or dichloromethane is having the highest dipole moment, followed by methyl chloride or chloromethane. Second is methyl chloride or chloromethane. Third is 3-chlorine substituted. That is chloroform or trichloromethane. Chloroform or trichloromethane. Finally comes methane and carbon tetrachloride. Both of being highly symmetrical where all the dipole moments cancel. Both are having zero dipole moment. So this is the order to be made by heart. The number of hydrogen substituted by chlorine here, if you want to remember, 2 chlorine, then 1 chlorine, 2 chlorine case having the maximum dipole moment, then 1 chloro having the second case, then 3 chloro, then only 3, then 0 equal to 4. This is the key you have to remember here. 2 chlorine substituted is having the major dipole moment, maximum dipole moment, followed by 1 substituted, then comes 3 chlorine substituted, then comes 0 and 4 chloro substituted, which are having, the last two are having 0 dipole moment. Okay, that much for this video. Take care.